What's up, everyone? Today we're going to use 3 different methods, or you can think 3 different levels to solve the following system of equations, which I believe is equivalent to high school algebra level, or for some people it would be just middle school level. Namely, x plus y equals 8, y plus z equals 13, and z plus x equals 11. So before we move on to the solutions, let's pause the video for a bit and let yourself think about it. Also, please don't forget to like and subscribe, and if possible, please also share this video and also the link of my channel, so that there will be more people who can watch this video. Are you ready for it? Here we go. So here's the first method. And the first method is usually what algebra teacher would teach in the class of how to solve a system of equation, which is using substitution. So first method, we're going to rewrite the first equation. It doesn't really matter. So let's pick the first equation and let's try to rewrite the variable x in terms of other things. So from the first equation, we're going to subtract y on both sides to get x equals 8 minus y. Now, let's call this 1 prime, because it's just simply a manipulation of equation 1. What can we do now? Well, now we can just do a substitution. So we're going to substitute 1 prime into equation 3, which means now instead of having z plus x, we're going to have z plus the quantity 8 minus y equals 11. And if we move around the steps, we will get negative y plus z equals 11 minus 8 gives us 3. Good. So let's call this equation 4. Then we can just now combine the second equation and the fourth equation that we have. If we add them together, we will get the following. Notice that we have y plus a negative y, which cancels out, and we have z plus another z gives us 2z equals the right hand side, which is 13 plus 3, giving us 16. And we now just divide both sides by 2 to get z equals 16 over 2, which is 8. Great! We finally got the solution for one of the variables. So what should we do next? Of course, substitute back in. So if we substitute our answer, z equals 8, into our second equation, we now get y plus 8 equals 13, giving us y equals 5. Similarly, if we substitute z equals 8 into our third equation, which says z plus x equals 11, we get, instead of z, we replace it by the value 8 plus x equals 11. So if we solve for x, we get x equals 3. And therefore, we get our solution set, x equals 3, y equals 5, and z equals 8. That's it. So this is our first method, which is how most teachers would teach in class, by doing substitution and adding equations together to do the elimination. All right. Next, we're going to look at the second solution, or a second method. So in the second method, we don't need to use substitution anymore. All we need to do is to use elimination and adding the equations together. How do we do it? Here we go. So first, I'm going to add and pick any 2 equations. It doesn't really matter. And I just add the 2 equations together. Let's say we're going to add the first and the second equations together. Now what do we get? We have x plus y here, and then plus another y, gives us 2 copies of y, or 2y, plus, don't forget, there's another variable here, z, equals the sum of the right-hand side, which is 8 plus 13, giving us 21. So let's call this equation 4. Then what can we do? Well, let's see. We still have one equation didn't use yet, which is equation 3. In equation 3, we have z plus x on the left-hand side, which is the same as x plus z. So what can we do? Of course, we can just do the elimination by taking the newest equation, equation 4, minus the third equation, which is the original given equation that I haven't used yet. So let's see. The x will cancel out, the z will cancel out, and we end up with 2y on the left-hand side. On the right-hand side, we get 21 minus 11. So that's equal to 10. And to solve for y, we divide both sides by 2 and get y equals 10 over 2, which is 5. Now, since we already got one variable, the value of one of the variables, we can just substitute back in to the first 2 equations that we started off and get the values of the remaining variables. So if we substitute into our first equation, we now get x plus 5 equals 8, which yields x equals 3 as our answer. And if we substitute y equals 5 into our second equation, we now get 5 plus z equals 13. And if we subtract both sides by 5, we get z equals 8. So we get our answer again, x equals 3, y equals 5, and z equals 8. So this time we actually use a less step, and we still figure out the same we still figure out this answer, which is the same as what we got from the first method. Excellent. So finally, we're going to move on to the last method, which is even faster. But of course, the reason why it works is the setup that we have here. It has to have a particular setup to make it work. Otherwise, in general, it might not be as easy or less a step as how we usually do it, like in the first method or how a teacher teaches. Okay? So here we go. The third method that we're using, or the third way of solving this problem, is similar to the second one, but we're going to do something even crazier. We're going to add all the equations together. So let's see what happened. If we add all of them together on the left hand side, we have x plus an x gives us 2x. And then we have one copy of y and another copy of y to give us 2y. Lastly, we have z plus z giving us 2z, which is equal to the sum of the right hand side. 8 plus 13 is 21 plus 11 gives us 32. So now we can factor out all the 2's on the left hand side and then divide both sides by 2 to get x plus y plus z equals 16. So again, let's call this equation 4. Why do we want to do this? Here is the reason. If we look carefully, on the left hand side is the sum of all 3 variables. And from the given system of equations, we see that each equation is sum of any 2 variables. Meaning, if we're going to take the following, let's say if we take the equation 4 and then subtract with any of the equation, let's say equation 1, then we can see that x and y will be cancelled on the left-hand side, giving us z equals the difference on the right-hand side, which is 16 minus 8, which is 8. And with the same argument, we can get x equals 3 and y equals 5. And again, we see that the solution set that we just got is the same as the answers that we found from the first two methods. And more importantly, we actually save a lot of steps. We only have technically one step here, and then we can jump into the answers right away. Therefore, here is the third method that probably you won't heard of in class, but will work if we have a special setup. All right, so that's it. Thank you for watching. I'll see you guys next time.